Next speaker is Rafael Frongillo.
Thanks. Hi, everybody. So I'm going to tell you about some open problems in property elicitation. So let me just tell you what that is. So in property elicitation, we think about eliciting some information about something that you'll observe, this y here. So, sorry? Can't hear? Oh, just speaking. Okay, sorry. Um, so imagine you have some random variable taking values, say in the real line, and you have some set of distributions that you're interested in, which are the possible distributions for y, and a property just maps these distributions to some parameter that you would like to learn. And so we'll say that a loss function, which takes a value of this parameter r and a realization of y, we'll say that it elicits this property if the minimizer over all reports r of the expected loss, where the distribution of y is p, is gamma of p, the property value. And if this holds for all p, we say that the loss elicits this property. So you can think of this as characterizing what the loss minimizes as a function of the distribution. Just two quick examples. So squared loss elicits the mean, as is familiar, and absolute loss elicits the median. But of course, you could ask the same question for other losses and other properties. And in general, we want to understand this relationship between properties and losses. So before I tell you the open questions, why this model? So this is a useful way of thinking about empirical risk minimization. So the distribution in question could be the empirical distribution of, it could be a data set essentially, or it could be the true distribution that the data is drawn from. You could also use this as is done in statistics and finance, as a way of evaluating existing forecasts. So someone else could be producing forecasts, and you might want to measure how accurate those forecasts are. It also comes up as a building block in mechanism design, so peer prediction, prediction markets, and many other areas in that literature, and also some certain scenarios in online learning and other places where losses pop up. So the main questions, which have been open for some time, are very simple. Characterize all the properties that are elicitable, meaning that there's some loss. So all the properties that you can write as an expected minimizer of a loss. And characterize all the surrogates. So what are all the losses given some property that are minimized at the same value? So there's been a lot of work in this area, and recently it's been picked up in the learning theory community. And we know a lot of things. We know we have characterizations for one-dimensional properties, expected values, so Bregman divergences turn out to be the losses in that case. But both of these questions are still open in general. And let me just give you, I won't tell you what these pictures mean, but one of these depicts a property that is elicitable, and the other depicts one that is not elicitable. And we can prove both cases, but we don't really understand deeply. Okay, and I'll just wrap up talking about this notion of complexity, which has come up recently. So elicitation itself might not be the right definition for machine learning. This might be a closer definition for what we care about. So let's say the complexity, elicitation complexity of a property is the minimum dimension where you can write this property as a link of some other property that you can elicit, and that property has d dimensions. So as a quick example, it turns out the variance is not elicitable, but you can still compute it by eliciting the first two moments, which are elicitable as expected values, and then you can compute the variance from those. So we would say that the complexity of the variance is 2. So we know a little bit about this case. We have some type bounds for a class of risk measures, but basically everything else is open. And we'd like to characterize the complexity classes, but also the complexity of some basic statistics like the mode and central moments are open. So I think it's an exciting problem. There's also another paper from Colt last year that has some open questions. So please come talk to me if you're interested.